The National Electrical Code, specifically Article 310.15b3, addresses minimum bending radii for conductors. For conductors with insulation, the minimum radius is 8 times the conductor diameter. For conductors without insulation, the minimum radius increases to 10 times the conductor diameter. Visual aids can be extremely helpful. NEC Table 310.15b3 provides illustrations. Also consider referencing the Siemens Electrical Bending Guide and the Southwire Conductor Bending Guide for visual aids and detailed specifications. When working with 4/0 conductors, remember that the diameter is approximately 0.512 inches. Therefore, the minimum bending radius is 4.96 inches, which is calculated as 8 times 0.512. Given the space constraints in a 24-inch by 24-inch cabinet, several strategies can be employed to avoid compromising bending radii. Firstly, consider using 45-degree bends instead of 90-degree bends to ease the bend. Secondly, explore the use of wider conduits or wireways to provide more space for bending conductors. Thirdly, using copper bus can be more efficient, as it typically has a smaller bending radius than individual conductors, thus taking up less space. Power distribution blocks, or PDBs, present another challenge. If the PDB you are using only have full load side terminals, they might not be suitable for your parallel conductor application. You may need to use PDB with more terminals or investigate alternative connection methods to properly distribute the load among the parallel conductors. When implementing parallel conductors, it is essential to ensure that all conductors are the same length. Also, it's essential to ensure that they are securely connected at both ends to maintain equal current distribution and prevent overheating. The goal is to ensure each conductor carries its share of the current. Proper connections are critical. When you select conductors to put in parallel, make sure you select the same material and stranding as well as the same insulation type. If you are dealing with aluminum conductors, use aluminum terminations. If you are using copper conductors, use copper terminations. Make sure you do not mix aluminum and copper together, which can lead to galvanic corrosion. The location where the connection of these conductors will be is also an important variable. If these connections are going to be in a wet or damp location, be sure to select a termination that is rated for wet locations. These terminations typically include an oxide inhibitor as well as being fully encapsulated. This prevents water and contaminants from reaching the conductive components. Another very important factor is to verify the ampacity that the lug is rated for. Most lugs or terminations will have the ampacity and wire range printed directly on them. You can also refer to the manufacturer's specifications of the lug. Be sure that the lug is rated for the current it will be subjected to. Overheating can occur if the lug is not rated for the amperage passing through it. Once the conductors are terminated properly, be sure to use the correct torque value to tighten down on the lug. This information can be found on the lug itself, or it can be located on the manufacturer's specification sheets. Torque is important because if it is under-torqued, the connection can become loose, potentially leading to a hazardous situation. If it is over-torqued, you can damage the conductor as well as the termination itself. When installing conductors, it is important to support the conductors so that there is no strain on the terminations. Conductors can be supported by using straps, cable ties, or other approved methods. When running the cables in the equipment, be sure that all the cables are neatly bundled and secured. This makes it easier to troubleshoot in the future. Be sure that there are no sharp edges that can damage the insulation of the cable. Use bushings when entering enclosures. The NEC provides rules and regulations for correctly installing electrical components. Always refer to the NEC for the correct requirements for any electrical installation. It is revised every 3 years. The ampacity of conductors is dependent on the temperature rating of the conductor, the ambient temperature, and the number of current-carrying conductors that are installed together. Conductors that are exposed to higher temperatures have a lower ampacity. Conductors that are exposed to a higher ambient temperature also have a lower ampacity. If there are multiple current-carrying conductors bundled together in a raceway, they will also have a lower ampacity. This is because the heat generated by each conductor will increase the overall temperature inside of the raceway. The NEC provides tables for temperature correction and adjustment factors. All of these must be considered to ensure that the conductors are not overloaded. If the conductors are overloaded, the insulation can break down, leading to a short circuit or fire. Grounding and bonding are very important. Grounding provides a path for fault current to flow back to the source. Bonding ensures that all metallic parts of the electrical system are at the same potential. This reduces the risk of electric shock. Grounding electrode conductors must be sized according to the NEC. The size of the grounding electrode conductor is based on the size of the service entrance conductors. Bonding conductors must be sized according to the NEC as well. The size of the bonding conductors is based on the size of the overcurrent protection device. Ground fault protection is required for many electrical systems. Ground fault protection is designed to detect ground faults and to energize the circuit quickly. This reduces the risk of electric shock and fire. The NEC requires ground fault protection for certain types of equipment, such as motors, transformers, and switchgear. Surge protection is also recommended for electrical systems. Surge protection is designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices, or SPDs, should be installed at the service entrance and at sensitive electronic equipment. When installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions will provide specific information about the equipment, such as the voltage, current, and wiring requirement. It is also important to use the correct tools and equipment for the job. Using the wrong tools can damage the equipment or cause injury. Personal protective equipment, or PPE, should always be worn when working on electrical equipment. PPE includes safety glasses, gloves, and hearing protection. Arc flash protection may also be required. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. Arc flash can cause serious burns and other injuries. Electrical safety training is essential for anyone who works on electrical equipment. Electrical safety training will provide information about the hazards of electricity and how to work safely around electrical equipment. It will also provide information about the NEC and other electrical codes and standards. In addition to the NEC, there are other electrical codes and standards that may apply to your electrical installation. These codes and standards may be adopted by your state or local government. It is important to be familiar with all of the electrical codes and standards that apply to your electrical installation. Working with electricity can be dangerous. It is important to take the necessary precautions to protect yourself from electrical shock and other injuries. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to install and repair electrical equipment safely. Always remember to energize the circuit before working on any electrical equipment. Verify that the circuit is energized with a voltage tester. Lockout and tagout procedures should be followed to prevent the circuit from being accidentally energized. Never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity, and you could be electrocuted. Be aware of your surroundings when working on electrical equipment. Make sure that there are no other people nearby who could be injured. Avoid wearing metal jewelry when working on electrical equipment. Metal jewelry can conduct electricity and cause a shock. Inspect electrical cords and plugs regularly for damage. Replace damaged cords and plugs immediately. Do not overload electrical circuits. Overloading a circuit can cause a fire. Use extension cords safely. Do not use extension cords as a permanent wiring solution. Make sure that extension cords are properly sized for the load. Keep electrical equipment clean and dry. Dust and moisture can cause electrical equipment to malfunction. Have your electrical system inspected regularly by a qualified electrician. An electrical inspection can identify potential problems and prevent electrical fires. Always follow these safety precautions when working with electricity. These precautions can help to protect you from electrical shock and other injuries. If you are not sure how to do something safely, ask a qualified electrician for help. Electricity is a powerful force that can be dangerous if it is not handled properly. By following these safety precautions, you can protect yourself and others from electrical hazards. Remember, safety is always the top priority when working with electricity. When dealing with bending radius, another factor to consider is the type of conduit you are using. Different types of conduits, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and PVC conduit, have different bending characteristics and requirements. Rigid metal conduit, or RMC, generally requires larger bending radii due to its stiffness. Electrical metallic tubing, or IMT, is more flexible and can accommodate smaller bending radii. PVC conduit is also flexible, but it can be prone to cracking if bent too sharply, especially in cold weather. The type of bending equipment you use also affects the bending radius. Hand benders are suitable for smaller sizes of conduit, while hydraulic benders are necessary for larger sizes and for bending rigid metal conduit. Using the correct bending equipment ensures that the conduit is bent smoothly and accurately, without kinking or flattening. When making multiple bends in a conduit run, it is important to maintain consistent bending radii and to avoid exceeding the maximum allowable number of bends between pull points. The NEC specifies the maximum number of bends allowed in a conduit run to prevent excessive pulling tension on the conductors. Pulling tension can damage the conductors and make it difficult to install them properly. In addition to the bending radius, it is also important to consider the fill capacity of the conduit. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. Exceeding the fill capacity can make it difficult to pull the conductors, and it can also reduce the opacity of the conductors due to heat buildup. When calculating the conduit fill, it is important to include the area of all conductors, including the grounding conductor. The grounding conductor is an essential safety component of the electrical system, and it must be properly sized and installed. In some cases, it may be necessary to increase the size of the conduit to accommodate the grounding conductor. Proper planning is essential. Before starting any electrical installation, it is important to plan the layout of the wiring system carefully. This includes determining the location of all electrical outlets, switches, and equipment, as well as the routing of the conduit. A well-planned layout can minimize the number of bends required and make it easier to install the wiring. It is also important to consider the accessibility of the wiring for future maintenance and repairs. The wiring should be installed in a way that allows for easy access to all connections and splices. Access panels may be required in certain areas to provide access to concealed wiring. Documentation is also crucial. Keep accurate records of the electrical installation, including the location of all wiring, conduit, and equipment. This documentation can be helpful for future maintenance and repairs. It is also important to label all electrical panels and circuits clearly. Clear labeling can prevent confusion and make it easier to identify the correct circuit in case of an emergency. Always consult the NEC and other applicable codes and standards to ensure that your electrical installation is safe and compliant. If you have any questions or concerns, consult a qualified electrician. Remember that working with electricity can be dangerous, and it is always best to err on the side of caution.